Multiplication, commutative. What does commutative mean? It's a big word, I know. But commutative just simply means you can switch the factors in a multiplication problem, but the product is still the same. What is a factor? A factor are the two numbers that you are multiplying together, and the product is the answer you get when you multiply. So if you read it again, you can switch the two numbers that you multiply together in a multiplication problem, but the answer when you multiply is still the same. Here's an example. 3 times 5 equals 15, but 5 times 3 also equals 15. You can see the factors 3 and 5 are switched to 5 and 3 in this problem, but the answer, the product, is still exactly the same. Let's take a look about why using arrays. It says, what happens when an array is turned on its side? The rows become columns and columns become rows, but you still have the same amount of dots in your array or objects. So let's look at the problem 3 times 5. Why is 3 first? Rows come first in the multiplication. So you multiply the rows times the columns. Now I'm going to write R times C. So we have 3 rows. Here they are. 1, 2, 3 times 5 columns. 1, 2, 3, 4, 5. Columns go up and down. Rows go side to side. So we have 3 times 5. But no matter what, you can see that there are still 15 dots here. Over here, we have 5 rows. You can see the arrows pointing side to side for 5. And we have 3 columns. You can see the arrows pointing up and down for 3 columns. So we multiply the rows first, in this case, which is 5, times the number of columns there are. And we still get a product of 15. Why? Because if you count, you still can count 15 dots or objects in the array. So you can count by 3, 3, 6, 9, 12, 15. You can count by 5, 5, 10, 15. And the same here. 5, 10, 15, or 3, 6, 9, 12, 15. Again, this is called the commutative property, and we used an array to show you what that means. How are the equations different? They're only different because the rows are 3 and the columns are 5, or if you use this expression, this would mean the rows would be 4 and the columns would be 5. Or in this one, the rows would be 5 and the columns would be 4. Does this change the product? We know that the answer is no, because we just proved it above by making an array. And this is what the commutative property is all about. Why don't you explore this using equal groups? How could you show commutative using equal groups? If you explored the same thing, commutative, using equal groups, you can see that the commutative property still works. So here I have 4 groups, and I've circled it. And in each group, the size of the groups are 5. But altogether, I still have a total of 20. So the number of groups times the number in each group, which is the size of the group, gives me a product of 20. So the factors here start with the groups and multiplies the size, and it gives you the product, and it's 20. But if we try it the other way, if we made 5 groups here, and we put 4 in each group, we still have a product of 20 as well. So the commutative property does work whether you use equal groups or you use arrays. And so the commutative property works because no matter which way you put it, you still end up with the same total number.